Question number 41. A 10 cm long rod carries a charge of 50 microcoulomb distributed uniformly along its length. Find the magnitude of the electric field at a point 10 centimeter from both ends of the rod. Here, this is rod AB, whose length is 10 centimeter. And from midpoint, this is point which is 10 centimeter from both the ends. So this will also be 10, this is 5. So by using Pythagoras theorem, we can get y equal to root of 100 minus 25, that is 5 root 3 centimeter. Now we can apply the formula. The formula is very simple. E equal to Q divided by 2 pi epsilon naught, the root of L square plus 4y square. Here Q equal to 50 into 10 to the power minus 6 coulomb, L equal to 10 centimeter, and Y is this distance, which is 5 root 3 centimeter. And after putting the values, we will get E equal to 5.2 into 10 to the power 5 Newton per coulomb. So here we have used the formula for getting the value of electric field. Now let's try to derive the formula. So we are going to derive this formula on next page. So here we consider a charged rod, and this is the point where electric field is to be found. So from center of the rod, we take a current element dx at distance x from here, and then we try to find out electric field due to this current element. So due to this element, electric field will be directed like this. It will have two components. One component will be dE sine theta in this direction, and d cos theta will be in this direction. Similarly, if we consider another current element here, so its field will also be like this. So dE cos theta will be in this direction. Sorry, d sine theta will be in this direction, and d cos theta will be in this direction, because field will be directed like this. So we can say net field will be due to cos theta components only. So first we write lambda, which is charge per unit length. So charge Q is distributed over length L, and for current element dx, it will be lambda. So for this current element, say length is dx, so for this charge will be dq, and that will be lambda dx. So lambda is q upon L times dx. Now electric field due to this current element will be dq divided by 4 pi epsilon naught, and this distance is suppose r, so r square. So we put the values, so it will be q upon L times dx divided by 4 pi epsilon naught, and r is x square plus y square. As I told you that net field is due to cos theta component, so we can say E will be integration minus L by 2 to plus L by 2 from here to here, and then we write d cos theta and we put the values. So here cos theta is even function, so we can also write this limit of 0 to L by 2 and then d cos theta. D cos theta, and since dx is also to be replaced, so this dx here I have not written, so it will be d cos theta, and when we write dE, so it will become twice of 0 to L by 2, and dE will be equal to q upon L dx divided by 4 pi epsilon naught x square plus y square times cos theta will be, if this is theta, then pi upon r, so that is y divided by r is x square plus y square power half. So we further write it as 2qy divided by 4 pi epsilon naught and times L integration 0 to L by 2 and then dx divided by x square plus y square whole power 3 by 2. Now we can do substitution. So here this x varies but y is constant. So we can replace x in terms of y. So we write x tan theta. Sorry, y tan theta equal to x, then y sec square theta d theta will be dx, and this term will become y square tan square theta plus y square whole power 3 by 2. So this will give y cube times sec cube theta. So our integral will change and we will get e equal to this 2 will cancel out this 2. So qy divided by 2 pi epsilon naught L, and here in a numerator dx is y sec square theta d theta, and here there is sec cube theta, so 1 sec theta will be left in denominator, so we can write it 0 to L by 2, and in place of dx it is y sec square theta d theta divided by, in denominator we are getting y cube times sec cube theta. So sec square theta will cancel out from here, sec theta will be left, one y will also cancel out, but another y is also there, so only y will be left in denominator. So we can say that it is q equal to 2 pi epsilon naught L times y integration 0 to L by 2, 1 upon sec theta will become cos theta d theta. Now we integrate it, so we will be left with sine theta. Here we have not changed the limits when we have done substitution, so we have to go back for that. So q upon 2 pi epsilon naught Ly times, this will become sine theta, limits 0 to L by 2. But we have to convert sine theta from this triangle. So here we have assumed y tan theta equal to x. It means tan theta equal to x upon y. So here triangle we can make. So this is x, y. So this will be root of x square plus y square. So sine theta will be y upon root of. So q upon 2 pi epsilon naught Ly times, this will become x upon root of x square plus y square, then limit 0 to L by 2. Now further, we put the values. So we put the limit. So it will become q upon 2 pi epsilon naught Ly, and then this will become L by 2, and here this will become root of L square by 4 inside the root plus y square. So if we simplify it further, so we will get this will become E equals q upon 2 pi epsilon naught Ly times. This will become L by 2, and from here, if we take LCM, this 4 will go in numerator, so it will become 2, and inside the root we will be left with L square plus 4y square. So 2 will cancel out. So, and this L will also cancel out. So we will left with q upon 2 pi epsilon naught y times root of L square plus 4y square. If we want to make it 4 pi epsilon naught, so we can multiply by 2. in numerator and denominator. So 2q divided by 4 pi epsilon dot y times root of L square plus 4y square. And this was the formula that we have made use while calculating the answer. Thank you for watching.